Another really cool benefit in the world of NSX is the ability to do layer 3 routing and implementing virtualized layer 3 routers. And this concept is known as distributed routing, and let me tell you why. So let's imagine we have a couple of VMs running here on ESXi-A. So we'll go ahead and put one here, we'll call it A-1, and a second VM over here, and we'll call that A-2. And then over here at ESXi-B, let's imagine we have a virtual machine named B-1, and a second VM that's running over here on ESXi-B called B-2. And let's imagine furthermore that instead of connecting them all to a common overlay segment so they'd all be on the same subnet, we want to have multiple subnets that are implemented in software. So for example, maybe we're trying to create a topology that looks like this. This would be a logical layer 3 IP router, and then we could have a network segment down here, and maybe that network segment is the 10.10 network. And the router on this interface here could use the IP address of .1 on the 10.10.0 network. And let's imagine a second interface here off this router. And let's imagine yet another network segment over here. And this one, let's use 10.20 for the IP addressing space. And for the default gateway address up here at the router, we'll use .1 on the 10.20 network. And then for connectivity of our VMs, let's mix it up a little bit. Let's go ahead and place these 4 VMs. We'll place A1 and B1 on the 10.10 network. So we'll put those guys right here in blue, just to kind of color code them. So there's A1, that VM, and there's B1, that VM. And then over here on the 10.20 network, let's go ahead and put A2, which is this VM right here, and also B2. So we'll put that right here. And then through static configuration of their IP addressing information or through DHCP services, each of these VMs on the 10.10.0 network would have an IP address beginning with 10.10.0, and for a default gateway, again, whether it's statically configured or they learned it via DHCP, they would use .1 on the 10.10.0 network as their default gateway. And over here, A2 and B2 would use 10.20.0.1 as their default gateway if they ever needed forward traffic off of their local network. And here's the magic behind making that happen. We're still going to use overlay segments, so we'll create an NSX overlay segment, and we can name it whatever we want. Let's go ahead and call this one Seg10. And in NSX, whenever you see an overlay segment, you can kind of think of it like a logical broadcast domain, which is what it is, or like a logical VLAN or a logical single VLAN switch. And we'll make another one right here for segment 20. So we create those overlay segments just like we did a couple videos ago, and then we would logically place a gateway, a layer 3 router that's connected to both of those segments. So for the interface that connects up to segment 10, we could use, for example, .1 or any other address that's not being used on the network segment. And over here, we could use .1 as well on the 10.20 network. And that's how we can logically implement routing. Now, it's called a distributed router. And the acronym is DR for distributed router. Now that acronym DR also has other meanings in different protocols such as OSPF, but in the world of NSX, it simply refers to a logical layer 3 router that's been implemented in NSX. And let's talk more about why it's called a distributed router and not just a router. So let's put some IP addressing on these VMs. So A1, let's imagine its IP address is .51, and B1 is at .52. And A2 over here is at .51 on the 10.20 network, and B2 is at .52. So I'll label those up here as well. So let's imagine that this VM right here at 10.10.0.51 connected to this segment right here, segment 10, wants to go ahead and send traffic over to VM A2, which is at 10.20.0.51. The flow of the traffic would go something like this. The client would realize that destination is not on its local subnet. It would send it off to its default gateway. This router would make a routing decision based on its routing table and then forward it down to this client right here, who would then receive that traffic and then respond back via its default gateway, and the response would be forwarded back to the original client here, A1. Now, the reason that in NSX they call this a distributed router is because each of the host transport nodes in our topology here, which is ESXi-A and ESXi-B, effectively, they have a copy. They know about that logical routing. It's been communicated to them from the NSX manager. Or in a production environment, you're likely to have more than just one NSX manager. It would be a cluster of NSX managers for fault tolerance. But in our lab, we have a single NSX manager that has communicated, once we have this configured, communicated all that routing information to both of our host transport nodes. So the cool thing is, if this VM wants to send traffic to this VM or vice versa, and we've implemented this topology, because this host transport node, ESXi-A, knows about that routing table here in the distributed router, It, meaning ESXi can make those routing decisions on its own, and that traffic never has to leave ESXi. So logically, all the routing is done back and forth between the two subnets going through the gateway, but all of that is done in the mind and heart here on the host transport node ESXi. So let's clean that up a little bit and take a look at one other scenario before we implement this and verify it together. Let's imagine that this VM right here, A1, wants to communicate over to B2. So once again, that traffic would be sent up logically to the router, who would make a routing decision, and then forward it down to that VM. And then for the response would go in the reverse direction as such. So the two parties here are A1, this VM over here, and B2, which is this VM over here. Now, because those two VMs are on two different ESXi hosts, there is going to be some sending of that traffic over the tunnel. And we would use Geneve encapsulation for the tunneling, as the traffic between this VM and this VM is being sent over the tunnel, which is effectively going over the transport network for the delivery of all that content. So logically, the traffic flow would be as we have shown over here, but in reality, the traffic would actually be sent over a tunnel from ESXi on the initial flow of traffic to ESXi, who would then do the final delivery. Now, for the routing decision regarding, this logical routing between subnet 1010 and subnet 1020, that logical routing is going to be done on the ESXi host transport node that is closest to the source. So for the initial flow of traffic, it's going to be ESXi that says, oh, that traffic needs to go from 1010 to 1020. And so it'll make the logical routing decision between 1010 and 1020, and then for the destination, it'll realize, based on what it learned from the NSX manager, oh, that destination host on 10.20 is reachable via ESXi, which once it's made the routing decision, it'll go ahead and then forward it over the tunnel to ESXi, who can do the final delivery. So for the routing decision, even though all of our ESXi hosts that are participating and have been enabled for NSX, although they all have a copy of the distributed router, it's going to be the host transport node that is closest to the source who's going to actually perform the routing decision before forwarding the traffic. And there's one other scenario I'd like to chat with you about, and it looks like this. Let's imagine that this VM right here, A1, wants to communicate with B1, which is right here. So logically, these two VMs are on the same exact logical layer 3 network, the 10.10.0 network. However, this first VM is over here on ESXi and the second VM is over here on ESXi. So from a routing perspective, that traffic would not involve the distributed router. So in this case, ESXi would see the traffic coming in from that VM. ESXi would know, based on this overlay segment, and based on the information it received from NSX, exactly where the destination is, which in this case would be over the tunnel. So host A would take the original traffic from this VM, encapsulate it, ship it over the tunnel from its tunnel endpoint over to the tunnel endpoint address for ESXi, who would de-encapsulate it, and then forward it on to that final VM. In this example, it's B1 at .52. So devices communicating within a network on the same subnet do not have to go through a logical router, and VMs that are communicating that are on different overlay segments, aka and also different IP subnets, that traffic, whether it's local on the ESXi host or on two different hosts, any traffic going between two different VMs is logically going to have to be processed and forwarded through the logical router. And again, fortunately, in a NSX environment with host transport nodes, each of our host transport nodes has a copy or knowledge of that distributed router, so any one of them can make the routing decision when it's needed. So what I'd like to do in our nested lab environment is walk through an example of implementing a couple of overlay segments and a logical router to do routing between them. Also, I want you to be aware that when we're implementing these logical layer 3 gateways, these layer 3 routers, there are a couple of different types. There is what's called a tier 1, and think of a tier like a level. There's also an option of implementing what's known as a tier 0. So think of it like a top-down approach. So if we wanted to have multiple routers involved, for example, we could have a tier 0 at the top of the heap, if you will, and then we could have, for example, router A, and another tier 1 as router B, and another tier 1 as router C, in the event that we want more than just a single router. So we could have network segments, one or more network segments on each of these as well. So in the event that we're implementing a hierarchy of routers, we'd start off with a T0 at the top, and then we could go ahead and put one or more T1s or tier 1s below it. So it's simply a way of organizing, are you a tier 0 or a tier 1? So for our initial example here of setting up a simple distributed router, we're just going to set up a tier 1, and that'll be this router right here. So it'll be an example of setting up a tier 1 router for the local routing between 10.10.0 and 10.20.0.